Welcome back, everybody. Today we're going to explore 3.3, the power of exponential growth, or why banks pay you to give them money. We're going to be using our book in order to explore that, plus maybe a calculator in the form of a spreadsheet. So please make sure you have those available. If we open up our book, we are going to see a situation you're probably pretty familiar with. Many of you have $1,000 or so in bar mitzvah gifts, etc. And as soon as you get it, your parents and everybody tells you very seriously, open an account in a bank so it gets interest. The question is, why do they tell you to do that? And how difference could it possibly make, even by as soon as, like, let's say you graduate high school? So we're going to say Kyra has been babysitting since 6th grade. She saved $1,000 and she wants to open an account at the bank so she earns interest. Simple banks place simple interest at the rate of 10%. How much money will Kyra have after a year, after 2 years, if she does not add money to her account, after 5 years? So the idea works like this. Right now, Kyra has $1,000. At the end of the year, the bank will pay her interest or 10% of $1,000 or $100. That means at the end of next year, she'll have 1,000 plus 100 or 1,100 here, just like it writes here, 1,000 plus 10% of 1,000, or you can do it algebraically factoring out 1,000, which says 1 and 10%, or $1,100. So just by letting her money sit for a year, she gets a free $100, which not too bad. Let's see what happens if you do that over the course of, let's say, 5 years. So at the end of the first year, now year 2, she has $1,100. 10% of that is her interest. If you go ahead and do the arithmetic on that, she has $1,200. Again, not only is she getting more money than she originally has, it's going faster. She's not getting just $100 a year. Now she's got $110. Now, before you scorn a mere $10, see what happens in year 3. In year 3, we go through the same process. The amount from the year before plus 10% is $1,331. Again, accelerating, not just $100 more, not just $110, but $130. If you do that same calculation, it's of 135. And then here is an increase of 150. It'll continue to increase faster and faster and faster, which is why exponential growth is the secret powerhouse behind almost every single financial experiment out there. In order to understand this in a more organized fashion, I'd like to introduce you to the power of spreadsheets. Spreadsheets are this wonderful tool that were literally invented to handle this exact type of problem. So if we can get to a spreadsheet is basically a way of organizing a lot of information in a logical way. All the information, all the data is organized by column and then by row, like so. So if in year 0, Kyra has a principal or $1,000, and then she gets, let's see, 10% of that, we can use this to calculate it by saying this is equal to the data in column B, row 5, or $1,000, times 10% for $100. Now, you might be saying, Mrs. Carl, this is really easy to do just by myself. I don't need to, write this down. Bear with me for a second, because the first step is really easy. Where it becomes really powerful is when we're able to repeat it. So then at the end of the year, her balance is 1,000 plus 100. And then we can start off the next week by saying, this should be the information in D5. Notice that copies it right ahead. Now watch what's really cool about this. I can then copy by pulling this down, and this will in turn copy everything from before. And as I pull it down, notice it's doing all my calculation for me. Let's explore the power of this in class. I'll see you there.